Alright, so we've got our MAAS server set up, and I've got the video stopped right here as I'm re-recording over what was actually a video before that I didn't record the audio for some reason. So anyhow, this is MAAS, MAAS version 2.1.3. Running on Ubuntu 16.04. I've got a virtual machine set up. We've got a whole bunch of virtuals set up on one physical server, and then I've got another physical server which is actually a chassis that has 4 nodes inside of it, which are kind of like basically servers in themselves. So the disk array in the front is kind of shared or partitioned into 4 nodes. It's what they call a cloud server. So essentially it's one big chassis. It weighs about 60 pounds, 60, 70 pounds, and it's got 4 nodes in the back that you slide in and out. Each one has 2 network cards and an IPMI. So what I'm showing here on this video is the power is already turned on, and I've already clicked the take action and hit the commission selection. When you boot them up, the system kind of just recognizes them, and it'll say new underneath the status. As you can see here, it doesn't know what's on those units yet. So I'm gonna play the video here, and just see it commissioning. So now you can see, I'm just showing you here the on, how each one is powered on. It's again done through IPMI. So I've got 3 networks set up here that this server is attached to. One is the internet-based one is a data network, or what I'm calling a data network, and one is an IPMI network. Now the IPMI network is isolated. It doesn't have any routing out. The data network routes out to the internet, and then the other network I'm running all the VMs on. And the reason I'm running them on a separate network is because when I boot them up, I don't want it talking to the MAAS server asking for an IP address and a DHCP name and trying to commission through there. So those virtual machines I'm kind of keeping off that network, so I can set them up and then add them to the data network later, so that I can actually use them for services on the data network without actually having them commissioning through the MAAS system. So, and of course the MAAS server is a static IP on that network, which the data network is a 10.21.0.0 network is what I'm using, but you could use anything you want. Alright, so now we're going to start seeing stuff kind of populate here. Here it goes. There's the first one, and then the RAM came in. The second one, RAM came in. Third, RAM. Fourth, RAM. Disks start populating with the disk sizes. Now each of these servers has 6 actual slots. And 3 of the servers I just have 148 gig. It's actually it's 146, but for some reason it shows as 147. Probably the differences in storage sizes that they see, but just a Fujitsu 15K SAS drive that's in there. And one of the servers, I think it's this one right here actually, it actually has 2 of those disks in it because I've built it for redundancy. I just have a RAID 1 set up. I'm doing that because on that node I'm going to have it as a master for the Mesosphere environment that I'm building using the community edition of Mesosphere. This system is actually all being set up for a Mesosphere setup. So here's me just outlining the cores and all that information. I'll pause. Alright, so now once the stuff has been collected, I'm just circling the information. Now you're going to see these switch over from commissioning to ready. And ready is a point where you can actually install the operating system. Now you're going to see all these transition out from ready to power off. So you're going to see those green lights there. They're going to start turning gray. And there goes the first one, second one, third one. So again, IPMI is controlling all the power on the server. I'm not even physically touching the server. It's in another room. I can only power so much in my office. Alright, so now we're ready to actually start commissioning. So now I'm going to go over and showing that it's ready. We're going to go up to actions up there, and then we're going to actually go down to deploy. And I'm just showing you the different versions. Inside the system in MAAS, you can actually download Ubuntu and CentOS in version 2.0. So here, let's go into the images, and you'll see I've got downloading 1604, and of course it's synced 7.0 for CentOS, but you can do 6 as well. Those are both synced. So see how everything's synced up. There's other software you can download, or other images you can download there. Here, once you select things for action, it automatically filters the list. So as you can see, I've got all these other machines in here that have already been deployed. Those are all virtual machines, except for the ones that have the power icon, which is a little grayed out power icon. That's just kind of what I'm pointing out there with the cursor. So now I've got them all selected. I'm going to deploy. So I just want to show you here that I've checked all these. I'm going to check them all again. You can see that I'm checked. I'm going to go down to deploy. It filters the list again automatically, because realistically you only want to see the ones you're working on anyways. So kind of like that. It gives you a selection of the operating system. I'm just recircling around the things. I've hit go, and you'll see these start to actually deploy. So as you can see, the icons go from gray to green there, which means that the IPMI interface was initialized, or set a message to initialize the system. And now the machines are actually turning on, and they are deploying CentOS. Now it goes through a series of reboots, so it takes a bit. So I want to go in here and I'm going to edit a machine so that you can kind of see what the machine looks like. Now the virtuals, when you bring them online, you actually have to set them as manual power control, but if you look in here, here's the hardware. You can see the hardware, the disks, the operating system I'm installing. Here's the power control piece. Notice I'm doing IPMI. It automatically detects all the interfaces for network, and I have auto assign set up with a pool of IPs, so it's only doing that for the primary one. Here's the disk it recognized and extent 4. Now, if you're using a RAID 1, which I am on one of the units, you won't show up here because they can't see that. Here's an event log of everything that's occurred. Note that I'm powering things on here, and that's all done through the IPMI piece, which I'm going to show that node powered on, and we'll go up, and here's the IPMI. So you can kind of see MAAS sets all that up. As long as it's accessible, it will do that. You can also click the check now to see if power is on at the top. We'll go back to the list of nodes here. Just click on a different one so you can kind of see the same setup pretty much. The more network cards you have, the more that are listed. Now, interestingly enough, with Ubuntu, you can assign and you can bond those interfaces. With CentOS, all you can do is let it auto assign. So you can configure the other one, I believe, is auto assign too. But I mean, unless you want it to be assigned to auto for that network, it really doesn't help that much, I guess. What I'm actually doing is I'm using Ansible later with a script to automatically set those up. Just Ansible itself, you run a script, and based on what your script program's for. So my script is programmed in to go in and adjust those interfaces and that information, create a bond 0, enable bonding, and go on to the next steps, which I have a bunch of steps to install a bunch of packages. The packages are there to help with the Mesos deployment. So here you can actually see the tags. The ones I'm going to click off here are all the ones that are actually virtuals. So these are all virtual machines that I set up. Notice they only have 2 cores and 8 gigs of memory, 2 cores and 4 gigs. Very light, of course. These tags you can actually assign per unit. I'm just going to show you the other tags here so you can see, like, if you have SSD storage, if you've got rotaries. Now the server's got all rotaries in it, the physical server, and for some reason all the VMwares are seen as rotaries too. Technically they are running on rotaries, so maybe it is actually detecting that correctly. I do have CentOS loaded on all of them, so hence the CentOS. Now we'll go into one of these and I'll show you how to assign a tag, which is pretty cool. You just hit edit up here, and you can type in the tag you want. Now this is going to be an agent server for Mesos, so I'm applying the agent tag. And you can see, look, I changed it to 3 now instead of 2. And I'll go on to the next one here. Do the same thing again. Agent. We'll save it, and then we'll go on to the next one. And of course, I'll show you that we have 4. Until cataloging this. You can actually write a script that will pull that information out and then act upon it. So I guess if you were setting up a system and spinning all the servers up at one time, you could do that. Now this server I'm going to make a master, so I've assigned it as master. And now you'll see in the tags, Daring Beetle, yeah, this one's actually a master already. I already have my Mesosphere environment set up, but I'm actually setting up a physical node to add. So there's the 2 masters I put on, the 5 agents, and the 7 virtuals. Now the virtual tag is actually automatically created and applied by MAAS when it recognizes it's a virtual. So I thought that was kind of interesting too. The MAAS, this version 2.0, seems to be much better set up than the version 1.0 that I had tried back probably 2 years ago. It just was missing some stuff, and I ended up setting up Juju to kind of work with it and do other things, but it never really. It kind of became centric to Ubuntu, most of the stuff, the setup, and the reason I'm deploying CentOS in this particular setup is that CentOS is one of the only 2 supported OSs for Mesosphere. So the other one being CoreOS. Now Ubuntu doesn't support CoreOS in the MAAS deployment. So if you wanted to do a bare metal load of CoreOS, you'd actually use something called Matchbox. And that's like a scripted platform piece. So there's me pointing out the version that I'm on. And this is actually running on a virtual machine. MAAS is installed on an Ubuntu 16, which is a virtual machine, which I'm just using that to deploy. It's great because I've got it on a server with 6 actual network cards on it, and I'm able to, of course, attach to various networks, doing that, partitioning off the networking, and then just telling the virtual you're connected to A or B or C. So, and of course, the MAAS server is connected to 2 different networks, so it can get to the internet and also is manageable from that network, but also can talk to the IPMI network. It can talk to boot the machines up. Nobody else is talking to the IPMI network except for the physical machines. Obviously you don't want people on your management network touching your IPMI stuff, so I've got it segregated, and that's how it will go when it goes into the production environment. Alright, so at this point you notice they've changed over from deploying to deployed. These machines are ready to go. Again, these are 4 physical nodes and a physical chassis that are basically 4 individual servers. One more point too to make out here is that alright, just had to pause for a second. Alright, that these names right here are actually automatically set up and applied to machines by the MAAS system. And of course it puts that .MAAS on there, so if you were to bring up a window, I think I have a window here. Alright, so here's this window. I've actually got up driven man. Note here, driven man. And driven man is right here. So you can actually ping bosscali actually just bosscali. It'll come back because this server is set up to use, by default, MAAS sets up the server to use it as the DNS and also it as the DHCP. So if I was to look at the network properties, let's just do, well, it's kind of hard to, I've already applied the script to this machine, so this machine itself Let's make this full screen here. That'd be okay. We're a little outside the screen. Let's just make it bigger. Alright, so I can actually look at this, and you can see, just go up a little bit here. Alright, so bond 0 is what I automatically create. Bond 0 is the interface that includes the ENS192 and ENS224. Those are the default names now that MAAS assigns the interfaces on your machine. So if they, like CentOS still uses Etho and Etho 0 and Etho 1, it automatically renames them during the installation. That's part of the new kernel in 16, as well as the Linux standard, I guess. So they're kind of enforcing that name set on here, which is kind of helpful because you really need that. But you can also see the interface name inside the MAAS interface. So if I was to bring up the live one that I had, go back over here. So that's the Mesosphere Slack channel, and I was to go into Boscali here, you can actually see in here, here's the actual name. So I'm curious actually, because these new nodes are ones I haven't messed with before, and I'm curious to see what it did with these. Okay, so this becomes complicated for scripting because it named these interfaces EN01 and EN02. Not really sure why it chose that name, but that does complicate my script a little bit. I guess I'll just retool it later. It's just a name anyways. So again, as you can see that this is CentOS 7, so all it did was apply an IP address here, and this becomes a sticky IP. So auto assign in MAAS automatically becomes a sticky IP. It won't go away until the server is removed. So if I was to come in here and delete this server, that's when it would actually release this IP address. So I can reboot this server 100 times, it will still come back with this name. But that's important to note because if we come in here and we'll look at Boscali, which is the one we're on, you'll see that the sticky IP on this one is 104. So we'll bring up this window again, and you can see my bond 0 configuration. Am I on Boscali? I am. Okay. Is 102. Wait a second here. Oh, sorry. Okay. I got my servers mixed up. Alright, I'm on Driven Man, so I was like, that can't be right. There's no way. I was pinging Boscali, but we were actually on Driven Man. So, alright, so Driven Man, now that I have the correct one, is 102. And we're on 102, so you can see that this is a sticky IP. So, just to show you this, if I go into, let me make sure I'm actually recording in the screen. Oh, just in case you're wondering, these other interfaces were all set up by Mesosphere when I deployed the DCOS piece. So I can probably show you that in a second, but we'll come back to that because this is particular to MAAS. So I'm just going to go into configurations, and with CentOS, if you're not familiar with it, they have the interfaces in config files. So in like Ubuntu, you go into etc network interfaces file and you edit that. Well, with Ubuntu, with CentOS, they actually use individual files for each interface. So it kind of complicates things when you're trying to configure them all, in my opinion, but you know, that's just how people go. So if we were to do CTS, well, I can't even type today. System. No, it's this config network scripts. I have to remember this stuff. I'm an Ubuntu guy usually, so kind of screws with my head when I'm trying to remember this stuff. All right, so if you can see in here, here's the two physical interfaces right here, 192 and then 224, and then bond 0 is the bond we created. Now my script is doing that, so I haven't even touched that physically. But the great part here is that I'll show you what the actual file looks like. We'll just do a more on it, and you can see what's actually in the file. I'm using DHCP. I don't have an IP address assigned in here. I'm not doing anything with that. So it's actually pretty cool because I'm using that sticky IP rather than assigning things manually. So it actually works out pretty good because now I can remove this machine and put it in another building, and it will automatically pull an IP address from whatever setup I'm at there. So I don't have to worry about it actually, moving IPs around and editing these files manually. And the great part is if I was to move this to another MAAS setup, it could actually assign another sticky IP. So to me that's pretty useful, I guess, if you were moving things around. Maybe not useful to everybody, but here's the individual interfaces. So just to show you the 192 interface, again, it's bonded to bond 0, so bond 0. It's a slave, so yes, it's a slave to bond 0. This device is bond 0. Now normally what I do is I apply these and then I restart networking, but in my script, but that doesn't seem to work 100% of the time with CentOS, so I actually have my script set up to automatically just reboot the server, which I need to do at some point anyways when I enable the Docker overlay for Mesosphere, so it kind of works out anyways. I really don't like rebooting physical servers because they take forever. At least the older ones. The newer ones are much quicker, about 1 to 2 minutes at most, depending on if you're using UEFI or not, and that kind of stuff. So, I can show you the DCOS setup here. So that's essentially it for the CentOS machine that was created and deployed by MAAS. Everything else I've deployed to this machine has been deployed via Ansible scripts. So those are the scripts I was talking about for setting up the interfaces. All the configuration for Mesosphere nodes is in here too. So all of that was done with the scripting. I just ran the scripts. It configured all the nodes, rebooted them, brought them back up, got it all set, and then I used the Mesosphere deployment script, which is has like a 5-step option basically that loads prerequisites, then it checks, and then it deploys, and then it checks again with post-flight, and at that point you're online. So if I was to actually enable something like that, you can actually see my docs is set up here. Now again, these servers are all online right now, but I've only got 5 connected nodes because those are just the virtuals I connected. This is, to me, pretty cool setup. This is where you can spin up applications, and this is actually version 1.9. So if I was to spin up a single container, I could come in here and add the services. I could set the networking type. I could do volumes if I want, health checks, environmental variables, labels if I need labels. So there's all sorts of fun little settings, and of course if you don't like this way, you can just do a JSON configuration and run it. So it's pretty slick. You can limit stuff. You can just dump in text and hit go, dump in text and hit go, make things pretty quick. You can also, there's also an API in DCOS where you can just connect to the API and run a JSON and get it offline and get things running. So let's go back to the MAAS piece, what we're here to do. So the nodes, just to show you again, these are all virtuals, these ones without power notations. So, and actually I'll show you that too. When you do a virtual, when it first pulls it in, you actually have to change this right here to manual. Otherwise, it won't let you proceed further. So you'll see it as a new item once it boots up, sees it, and then shuts it down again. That's kind of how MAAS works. You boot up the node, it sees it, it kind of runs through a setup script initially, and then you can commission it. And then when you commission it, it powers it back up again, assuming you have an IPMI, of course, or some sort of management card that allows you to power a server up. Unfortunately, in the virtual machine environment that I'm running, my ESXi setup, it's standalone, so it doesn't have a control server, the vCenter server. so I can't actually use the VMware feature here, so I just set it to manual. And of course, manual, you hit commissioning, and then you have to go over to your vSphere client or your workstation client, depending on if you're using workstation or vSphere. Then you have to power it on, and then you'll see it commission up, and then it'll shut down again, and then you gotta say, okay, I want to make this deploy CentOS, and then you deploy CentOS, and then you go back to the vSphere client, you hit go. Power this on again, and then it powers it on, and at that point it fully deploys CentOS and it stays on. So after it's deployed, the server doesn't shut down again, which is kind of helpful. It makes the most sense too as far as like programmatically functioning. But I have seen this list expand, which is pretty cool. I even see here they have a PDU controller, so if you actually have a PDU attached to a server that has the network module in it, you can actually power on devices like that, which that's pretty useful. Looks like Digital Loggers has a PDU as well. PDUs, in case you don't know, those are just the very large power strips or a power module controller type unit that a server would be physically plugged into for power. So a very glorified power strip, if you will. But for metered PDUs that you see at a data center, you'll see network connections in them, and you can control the power actually on the power strip from that PDU. So that's kind of cool. I wonder what kind of features that they have. Yeah, so you can actually say what outlet number you want to turn on and the delay. So that would be kind of like the pseudo poor man's way of doing it. If you had a physical server that didn't have an IPMI card, you could actually run it that way. I can't say, well, there's no power off function here, so I guess you would have it shut down the system from the system, and then you could just physically power on that individual piece. But I don't know, not all servers would probably power on that way. They would probably come to a safety like start instead of actually powering up again. So I guess you'd have to set the BIOS to automatically power back on again. That's it for this video. Hopefully that explains some useful stuff. Look at the tags again. You can also do storage tags, which are pretty cool. I show you the networks here. I've got several subnets, so my data net, my IPMI net, and I've renamed all these. They come in as Fabric 0, Fabric 1, Fabric 2. Subnets are here. If you wanted to control DHCP, you'd actually click, not on that, you'd actually click on the untagged VLAN, and then from there you can take action to set up DHCP. I'm not always sure why they have this set up this way, but I'm sure it's covered in other videos as to maybe why they do that. So to me it's weird. And then this is just a name. So, but you can see under here I've got this network assigned to it. I'm assigning IPs from here. You can do reservations. So I've got reservations down here, and of course down here it tells you what IPs are currently being used. But I've got a dynamic, and then I've got a reserved. My reserved is a static IP network area where I don't want it assigning, and then I've got my dynamic one, which is the one that's assigned IPs during the commissioning piece. I didn't understand this quite until I started playing with it, but this is actually probably a good explanation to have on here since they don't really explain it that well. But the dynamic range is for when you start a machine up. It's given an IP during the whole commissioning process, but that IP changes once it gives it that sticky IP. So by having a reserved range, I can say, okay, don't assign any sticky IPs or dynamic IPs from this area. So the first 100 I'm reserving for my router, my MAAS node, my master nodes for DCOS or Mesosphere, and I have a bootstrap node too that you have to have for Mesosphere. So those are those pieces that I've got reserved. I reserved 100 because I've got a very large range set up with a 10 network, of course. And then I kind of took the last 255, I guess, Actually, it's more than that. It's about 500 IPs in this range I've got set up, and I set those to the dynamic reserved so that they can be used for that temporary commissioning piece, and then everything in between will be actually sticky assigned to the individual machines. So I like that piece. I really wish they would explain that as how it works, but that's just how it is. You'll see some of these. Yeah, you can see like these were actually applied to Ruling Kitten, which is one of the new the names are kind of funny sometimes, but these are all the temporary ones that these machines were given when they were booting up and commissioning. So you can kind of see, okay, Ruling Kitten was actually statically or sticky assigned 108. And it just goes in order, so as the machines come online and go, you get 108, 109, 110, because you don't really care for this as far as a sticky automatic IP. And these IP addresses don't change; they stay that way, which is great because as long as that machine's in the system and not deleted, you can just keep assigning IPs to the next machine without ever having to physically or manually assign an IP to any one server, which is kind of cool. Now you can go into a server. While I'm talking about this, I might as well do it. And you can say, we'll go into Boss Collie here. You can actually edit this stuff right here, and you can assign a static IP. I think I'm missing that functionality. Oh, okay, yeah, all right. So I can't do it right now because these are this is already configured, and of course, as they note here, custom support is only done with Ubuntu right now. So if I had a machine that was kind of ready or new, in there you can actually assign that information. You can actually assign static IPs. You can assign a dynamic. I think you can assign one inside the dynamic area too. You can, and of course, if it's Ubuntu, you can actually set up a bond. So you can actually create a bond interface and bond those two physical interfaces, and assign a static or dynamic IP to it and to that bond. And when the machine is fully commissioned, it will bond the interfaces and be online with that bonding. So that's kind of cool. I really wish they would do that with CentOS, because even though the process is different in the way CentOS works, it's not going to be different as far as later on as CentOS goes. So I just find it interesting that they don't support it currently, but they may just not have been able to get it into the build yet. It looks like they're moving forward with supporting CentOS, so it's kind of nice of them to support another image from another distribution. They do actually support custom images, but when you do custom images, apparently in version 2.0, I think you lose the ability to pull in these images here. So, and you can also do custom sources too, which is kind of cool. Let me see if I can come in here. Let's see here. Device discovery, which is very annoying actually, because anything on the networks, it tries to pull it in. Yeah, I don't see it in here. I think you set it up in custom back in that other area, and that's kind of not helpful for this video if I don't have it set up. You can also do your default, so automatically I have it set for deploying CentOS 7, so I don't have to click it every time. You can do your commissioning, so you can pick out what the minimum kernel is for your commissioning pieces. I don't know the specifics as to why you choose one or the other. I just have it set on low latency just because I'm hoping that it's a smaller image and it will load faster. There may be some capabilities I'm missing out by not using a different kernel for commissioning, but it's not that big a deal for me because I'm using Ansible to set them up later. You will create on your MAAS node, you will create a key, and you'll use that key when you create the user, and then that user will be created on each system and require that key to actually gain access. So if you noticed, I was logged in as CentOS. That's the one thing I did notice, is when a MAAS commissions nodes that are CentOS, it sets up the user as CentOS. So you actually have to do an SSH as CentOS. If I were to exit my session here, you'd see that I'm actually logged in under symadmin, but when I SSH over to one of these new nodes that was set up, I have to use CentOS. And of course I have my SSH key already set up in here to connect. So when I connect, I don't really have to do anything. Okay, well, I've recommissioned some nodes in the process, but here's one that I haven't connected to before. So, oops. We'll exit, and then I'll reconnect to it, and you can see, boom, there you go. So that's probably the greatest thing I think is, as far as this goes, is it does it all, uses the keys. You can actually add multiple keys in there, so when you connect, you could have multiple admins connecting. Now, realistically, when you set this stuff up and you're doing everything through Ansible, you shouldn't need to really touch those nodes. But one thing I can recommend is setting up a local user before you start bonding interfaces, because if something breaks, you have to go hard power the server if you're using SSH keys, unless you have a serial console, which most people don't have. So you're kind of out of luck. So I add a local console only user that allows me to interact with the console just in case something goes horribly wrong. But once your scripts are in place, it shouldn't be an issue. They should be tested, all that good stuff, before you push them into production. So that's it. Hopefully this is helpful.